ch14, chapter 14, problem number 20. For the following pairs of voltages and currents, indicate whether the element involved is a capacitor, inductor, or resistor, and find the value of C, L, or R if sufficient data is given. So you're given these equations here. What does it all mean? Well, the easiest way that I was taught to remember this is to remember Eli the Iceman. What does that mean? Well, if E is representative of voltage, L of inductance, I of current, and C of capacitance, the way that you remember this is the plus means that something is leading, okay? So let me put it another way. It doesn't necessarily mean that. You take these two values right here, all right? And V has a theta V of plus 50. I has a theta I of negative 40. So obviously plus 50 is greater than negative 40. Okay, you don't take the absolute values. So if theta V is greater than theta I, it's inductive, it's L. How do I know that? Well, if theta V is greater than theta I, that means the voltage is leading the current. So up here, E comes before I, which means the voltage is leading the current, it's inductive. If it's capacitive, the current is leading the voltage, it's the opposite. All right? Or you could say current lags the voltage for the first scenario. So they're saying V leads I by 90, and the way they got that is they took 50 minus a minus 90, and then they took the absolute value of that. So it's inductive. And then X sub L equals Vm divided by Im equals 550 divided by 11 equals 50 ohms. All right. So that's X sub L, the reactance, and they're asking you to find the value of the inductor, L. So using the formula before, X sub L equals omega times L. And we know that the omega in this equation is 377. So you take the 50 ohms divided by 377 radians per second, which is 132.63 millihenries. And also, just to let you know, 377, if you want to know what frequency that is, you divide it by 2 pi, and then it ends up being 60 hertz. It's just a little side note. So whenever you see that 377, then they're talking about a 60 hertz system. Same thing for part B. Theta V is negative 80. Theta I is a negative 170. So negative 80 is greater than negative 170. So you have this scenario again. You have the Eli. So your voltage is leading your current. It's an inductor. And you calculate it the same way. X sub L equals Vm divided by Im. So it'd be 36 divided by 4 equals 9 ohms. And then the inductor would be, okay, so there was a typo on here. I had to fix it. So in part B, it's also inductive. And X sub L ends up equal to 9 ohms. So again, using this formula up here, all right, X sub L equals omega L equals 2 pi FL. So we know what omega is. It's this number in here right before the T. So X sub L equals omega L. So L equals X sub L divided by omega equals 9 divided by 754 from here equals 0.01136 henries or 11.94 millihenries. In part C, okay, you see a scenario where theta V and theta I are the same number. So if theta V equals theta I, that means it's not leading or lagging. It's a purely resistive circuit. There could be an inductor or a capacitor in there, but they're canceling each other out. Or there may not be. And it may just be resistors in the circuit. Needless to say, if these two numbers are equal, that means it's purely resistive. V and I are in phase, so it's resistive. And then R just equals V sub m divided by I sub m, which is 10.5 divided by 1.5 equals 7 ohms.